we're starting with this um, chapter 4. Actually, we already have started chapter 4, isn't it? We already have seen chapter 4. I think number 5 slide we have seen. So this is the chapter 4. Just to tell you, we are talking about two random variable, and we talked about this joint cumulative distribution function, and that is actually this the joint CDF. uh, Joint CDF will be with a particular point, and then below that particular point, this is the particular point, and then we will have below this, I mean, in the left side of this X value, and then the lower side of this Y value. So this is the area that will be the joint CDF. We already have seen this one. Then then we already have seen the characteristics of the joint CDF. Already we have seen this one. Okay. And then from these characteristics, we have already solved this quiz 4.1. Okay. So if just for refreshing the memory, can you say what is this value? Number 4.
0.
0. Right. Because 1 minus infinity is there. Okay. So if any 1 minus infinity is there, that means at that particular point, we will have 0 CDF. Okay, then let's go to the next slide. Uh, we have already seen this one. Now let's see joint probability mass function. We have already seen the joint probability, I mean joint cumulative probability density function, or joint CDF, cumulative distribution function. From this joint CDF, how can we find this joint PDF or joint PMF actually? So remember one thing, this joint PMF is at the particular point, joint PMF will be that X value equals to X and Y value equals to Y. Say for example, we are having at a particular point. So at that particular point, what is the value of X and what is the value of Y? That will determine the probability mass function, or you can say the joint probability mass function. Okay. In the joint, in the normal probability mass function, what actually we have talked about, that for different value of a particular random variable, say x equal to x1, x equal to x2, x equal to x3, we we want to see all the probability of the particular single random variable. But we are seeing here a joint PMF where a combination of x and y will be there. Say for example, um, we are having 3 points. This point is having some probability like this. This is having some probability like this, and this is having some probability like this. Now the thing is, that particular point probability is determined by the x value and y value. Okay. And when I'm talking about, say, x equals to 1 and y equals to 1, then x equals to 1, y equals to 0, then x equals to 2, y equals to 2. Say these three combinations will have probabilities. Say for example 0.09, say 0.1, say 0.3. Okay. So previously, for a particular value of x, there was probability. But now a combination of x and y will have that value of probability. Okay. So I think this is clear now. Let's see the example, then it will be more clear. Test two integrated circuits, one after another. On each test, the possible outcomes are accept or reject. Assume that all circuits are acceptable with probability 0.9, before further moving, I want to talk about that this is something like accept, reject, two tests I am talking about, then accept, reject as well. Here also again two tests, accept, reject. Okay, now they are telling assume that all circuits are acceptable with probability 0.9. So this probability is 0.9. Then this probability will be 0.1. That probability is 0.9 and this probability is 0.1. Similarly, this one is 0.9 and this one is 0.1. Okay, let's see now. Count the number of acceptable circuit X. So X is what? X is number of acceptable circuit. And count the number of successful test Y before you observe the first reject. So Y is the successful test before you observe the first reject. Now they have told that actually we are doing only two tests. So if both are successful, then what will be the value of Y? Because we haven't seen any reject yet. So can we say that? So they are telling if both the tests are successful, then let the value of Y equals to 2. Okay. Now they are telling draw a tree diagram. Already we have drawn the tree diagram for the experiment and find the joint PMF of X and Y. So at first we have to find out what is the value of X for every branch. How many branches are there? There are 4 branch. 1, 2, 3, and then 4. Is it clear? There are 4 branch. Can you listen to me?
Yes, sir. Sir,
Okay.
successful tester এই পার্টটা বুঝলাম না।
Acha. So actually, now we will find out one by one. Let us first see that there are 4 branches. Now for this first branch, what is X and what is Y? X is what? X is the number of acceptable circuit. How many acceptable circuit in this branch?
Sir, 2.
2. Okay, fine. Now what is the value of Y? Y is the successful test before you observe the first reject. Actually, specifically, it is mentioned that when both are successful, then the Y value equals to 2. So it is already given. Both are successful, so Y is 2. It is already given. So from this, it will not be clear. Let us go to the next branch. In this branch, what is the value of X?
Sir, 1.
X equal to 1. Is it clear?
Yes,
Because
sir.
1 accept, 1 reject. Now, what is the Y value?
Sir, is y also equal to 1?
Y will also equals to 1 because look at that. What is Y? Y is successful test before you observe the first reject. So you have observed the first reject here, isn't it?
Yes, sir.
And before the first reject, you have a first acceptance. So there is one acceptance before the first reject. So the Y value should be equals to 1. Is it clear?
Yes, sir.
Okay. Now the thing is, what about this third branch? This
Sir,
third branch.
equals 1,
X
y
equals
equals
to 1, Y equals to
say 0.
Y equals to 0. Very good. Why? Because first time it is getting a reject. So before reject, there is no acceptance. That's why Y equals to 0. Is it clear? Everyone?
Yes, sir.
So the fourth one, what is the value of X?
Sir, x equals to 0.
X equals to 0 and Y equals to what?
Sir, 0.
Y equals to 0 as well. Because before reject, there is no acceptance. So we have found out now different branch metric And remember one thing, for the first branch, what is the probability? 0.9 into 0.9. That means 0.18. What about the second branch? 0.9 into 0.1. That is 0.09. The third one is also the same, 0.09. Fourth one is 0.01. So what is the idea behind this one? We have found different combination of x and y, and for every combination of x and y, we are finding a probability. And if I make it in a tabular form, that will give the joint PMF of x and y. Okay, now let's check our result. What actually they are selling. Look at this one. This is the idea that we have gone through. Okay, this is the tree diagram, and you can see that these are the probabilities, and these are the combination of x and y. Okay, so
Yes.
if I want to find out, already we have found out these things. Now the thing is, if I want to find out joint PMF, they're telling they can write by three ways the joint PMF. Look at this first one. In the first one, they're telling x equal to 0, y equal to 0, the probability is 0.01. Okay. This x equal to 0, y equal to 0, probability is 0.01. X equal to 1, y equal to 0 is 0.09. X equal to 1 and y equals to 1 is 0.09. And then x equal to 2 and y equal to 2, that will be equal to 0.81. So there are four probabilities. Combination, we can write the joint PMF like this, no problem. But some people prefer to write it in this way. In this way means there is a combination of x and y, and also there is a probability. So we know that there are four combinations, and then zero otherwise you have to write. We know how to write the PMF, and that is the probability of x comma y. Is it clear?
Yes, sir.
Okay. Another way, actually, we can also represent this joint PMF. Okay. So this joint PMF, just a minute, just a minute, just a minute. Okay. So we were talking about three different ways how to describe the joint PMF. Okay. The third way that we are talking about, the third way is something like we will record all the x, also we will write all the y, and then this one actually is the corresponding value of first column and first row. So that means x equal to 0, y equal to 0, that will give us this probability. Okay, this particular kind of expression actually we will use uh, to find out the uh, different kinds of marginal probabilities. We'll see. Hmm. So this is the way actually how it works. So is there any question regarding the PMF, joint PMF? If not, then we will go to the next slide. Look at this one. For discrete random variables x and y and any set B in the xy plane, the probability of the event xy in B is something like that. So what actually they are telling? They are telling that probability of B will be that particular probability where we will add all those joint probabilities whose X and Y will be the member of the B event. This is very important. If I want to find out probability of event B, then in event B, say for example, this is XY plane, and we are having a different value of PXY, and that is an event B. So what are we talking about? Probability of B will be addition of these members or these probabilities who are in event B. Okay. Now the thing is, let's see the example. The example is telling, continuing example 4.1, find the probability of the event B that X, the number of acceptable circuits, equals Y, the number of tests before observing the first failure. So in the previous example, we had 4 particular points, isn't it? If you can remember, if we go back, then maybe we can see. If we go back, look at this one. In this particular case, we had 4 different points, and that example 4.2 is telling we will have to find the probability of that particular event where X and Y are equal. So out of these 4 particular probability, in which case X and Y are equal? First one, yes. Second one, yes. Third one, no. Fourth one, yes. So if we add this one, and this one, that will give us the probability of that particular event where the X and Y values are equal, isn't it?
Yes, sir.
That's what actually we are doing. Okay, that's what we are doing. Look at this one. Probability of B is equal to 0, 0, 0, 1, 1, and 2, 2. So we are adding those 3 different probabilities, and we are getting the result 0.91, which is the probability of event B. Is it clear?
Yes, sir.
Okay. Now let's see the quiz 4.2. Okay. We've been given a joint PMF PQG for random variable Q and G. Okay. So similar like the previous example, this is another kind of example or something like that. We have some Q value, we have some Q value, and we have some G value. Okay. Now, every probability is actually for 2 values, one value for Q, another value for G. Say for example, this one 0.12. What is the corresponding Q and G?
1, 1.
1, 1, right? Q equals to 1, G equals to 1. All right. Now, calculate the following probabilities. What is that? Probability of Q equal to 0. How can we do that? Q equal to 0 means I'm taking actually all these G values. So if I add all the other probability, all the probabilities under this Q, then actually that will be probability of Q equal to 0. And that will be equal to 0.06 plus 0.18 plus 0.24 plus 0.12. Similarly, if I say probability of Q equals to 1, what will be that?
Sir, addition of 0.
0.04 plus 0.12 plus something like that. Okay. Number 2. What is the probability of Q equal to G?
0.06 plus 0.1.
Right. 0.06 plus 0.12. Because in this particular 2 probabilities, look at this one. In this particular 2 probabilities, the value of G and Q are same. For 0.06, value of q equal to 0 and g equal to 0. For the value of 0.12, the q equal to 1, g equal to 1. There is no other option for g equal to 2, q equal to 2. That's why we could not add this one, these two. But for this one, we have to add this 0.06 plus 0.12. Okay. What about number 3?
0.24 plus 0.12 plus 0.16 plus 0.
Is it? Why not 0.18 also?
Sir, in this case, G equals to 1.
In this case, g equals to 1, but q equals to 0.
Yes, sir.
Then also that, oh, sorry. I'm talking about the number 3. Number 3 is g more than 1. Definitely, we have to cut this one. G more than 1 means these 4. Okay. So when we are talking
Yes,
about g more than 1, then of course we have to use these 4. This one, this one, this one, and this one. Why will we are not taking this one? Because this is for g equals to 1. This is not for g equals to more than 1. Okay. What about this 4, number 4?
so in this case, we have to consider G1.
Right, right. Because in this case, we have to consider this one. We have to consider this one because that one case g is more than 0. This is also g is more than. This is also g more than. What about this case? This is also g more than q, also g more than q. So we will have 5 elements in this particular g more than q. Is it okay?
Yes, sir.
Others are understanding or not? I want feedback.
Yes, sir.
Okay. All right. So this is the quiz 4.2. Okay. Now we have the solution. You can understand. We have the solution. We have the solution, and we have the solution. Okay. So we can solve it by already we have solved it actually. Then we are talking about marginal PDF. What is the marginal PDF or PMF? Okay. In an experiment that produces two random variables x and y, it is always possible to consider one of the random variables y and ignore the other one x. What does it mean? Remember one thing, in the previous chapters, what we have done, we have taken either x or y, that is a single random variable. But in this chapter, we are considering double random variable, and we are also talking about joint random variable, joint PMF, joint CDF, like this one. So jointly we are talking about two kinds of random variable, but from these two we can actually go back to the single random variable by just ignoring one. Okay, and that will be called as the marginal PMF. All right. Now the marginal PMF, how can we do that? The marginal PMF can be done in two ways. Directly find the probability of y or probability of x, whatever it is, that is a single random variable. And then another way is by using the PMF of x, y, and then from PMF of x and y, we can find out the PMF of y or PMF of x. Now, how to do that? This is the way we will do that. If we have a joint probability like this one, and if I take all the values of y, that means all the values of one particular random variable, then I can find the other random variables marginal PMF. So if we have a joint PMF, from a joint PMF, we can easily find the marginal PMF by considering all the values of other random variable, or by summing all the random variables of the other random variable. Similarly, it is true for PY as well. I think it will be more clear if we go for an example. Okay. What is the example? The example says that In example 4.1, that's like the previous, that we are talking about the previous example. If you can remember, there were three possible options of PMF, and those three possible option of PMF, we have the last one like this. Okay, there is one side is X value, another side is Y value, and the cross section points are the probabilities. Okay, now from this joint PMF, it is very easy to find out the marginal PMF. How? Look at this. Say for example, I want to find out Px from that. If I want to find out Px, what are the values of X? We know we have here X equal to 0, X equal to 1, X equal to 2, isn't it? So if somehow we can find out the probability of X equal to 0, probability of X equal to 1, probability of X equal to 2, then we can find out easily the Pxx. All right. So the thing is, for X equal to 0, what is the probability? We already have seen that probability of X equal to 0, we have to take all the values of Y. Or we can say we have to take all the probabilities of Y. So probability of X equal to 0, that will be equals to 0.01 plus 0 plus 0. That is 0.01. For X equals to 1, that will be addition of these. That will become 0.18. And then probability of X equals to 2, that will be equal to 0.81. So if I say that probability of X will be equals to 0.01 for X equal to 0, 0.18 for X equals to 1, and 0.81 for X equals to 2, and then 0 otherwise. This is the same kind of PMF that we have seen in the last chapter. And as we are finding it from the joint PMF, that is called marginal PMF. Is it clear?
Yes, sir.
Yes, sir.
Okay. So the thing is, this marginal PMF actually is the idea that we are finding. Actually, it is from the joint PMF. So if we have the joint PMF, we can find out the marginal PMF as well. Let's see how they have proceed. They have done something like that, similar kind of thing, and we have seen that one. So the PMF, now they are finding the PMF of Y. We have found out the PX. Now they are also finding out the PY as well. So they have found the PX, they have found the PY. Look at this expression. This is very important. This is very important. The thing is, look at this joint PMF. That one was up to joint PMF, not that one, up to this one. This is an extra. This is an extra row, and this is an extra column. So what actually is this? This is an expression where we have both the joint probability and the marginal probability. So look at this one. This joint probability is actually producing the marginal probabilities. So when we will write Px, this x equal to 0, this addition will give us 0.01. These addition will give us 0.18. These addition will give us 0.81. Similarly, these addition will give us 0.1. These addition will give us 0.09. These addition will give us 0.1, 0.81. Okay, so this joint PMF expression can also be used to include the marginal probability as well. Marginal probability of X and marginal probability of Y. Is it clear?
Yes.
Any question? No. No question means very good. Okay. The thing is, we have this. Actually, that is one way. This is another way of writing. Already I have shown you that a px and py can be written in a different way. Okay. Now we are talking about joint PDF, probability density function. So far we are talking about the joint PMF. PMF is what? Probability mass function, and PMF actually is coming from the discrete value. That's why we are talking about some summation. But now when we are talking about joint probability density function, then we will talk about this integration, not the summation. So the joint PDF can be found out from the differentiation of CDF, or the CDF can be found out from the integration of the PDF. Okay, so the joint PDF or joint CDF can be found out from one another by using differentiation or integration. Let's see one example 4.4, how it works. Random variables x and y have joint PDF like this. Okay, joint PDF like this we can understand. This is the joint PDF, and that is C between that. So look at the drawing. If I want to draw this one, 0 to 5 and then 0 to 3. So we have a something like a rectangle kind of shape, and within this region, if it is taken, then there is some value between this region, and the joint probability value is equal to C. Okay, so find the constant C and probability of A. A is one event. What kind of event? This A is between 2 and 3. X value is between 2 and 3. Say 1, 2, 3, 4, 5, and then 1, 2, 3. So when I'm talking about X is between 2 and 3, X between 2 and 3, and then Y between 1 and 3. So actually, it is something like this one. Okay. So if we draw it like this, it will be something like this one. So that is the event A. Okay. So what they are telling, they are asking for finding the value of C, number one. Number two is they are asking for the probability of A, that is the probability of event A. So for finding C, how can we do that? We can use integration from minus infinity to infinity. If I integrate a probability, that will be equals to 1. We know that. If it is a joint probability, then we need to double integrate that. One will also be equals to 1, isn't it?
Yes, sir.
So if I follow the second one and we use this one, then actually what can we get? Actually, minus infinity to plus infinity, in both direction, actually even if you take it, there is no use, because outside this 0 to 3 and 0 to 5, there is nothing. So if I want to say that I want to take the x limit or y limit, say this is the y limit. What is the y limit? 0 to 3. What is the x limit? 0 to 5. And this fxy equals to c, then this will be dx dy, that will be equals to 1. Can we write it like that?
Yes, sir.
Okay, so if you integrate, then you will see that the value will be equals to 15c equals to 1, and then you will see that the c value will be equals to 1 by 15. Okay, so this c value equals to 1 by 15 that we have found out from the known equation. Now, if I put the value of C equals to 1 by 15, then we can find out the probability of A. How can we find the probability of A? We can use this C value 1 by 15, and then we can use this two limits. X limit, if I say that this is the dx dy, then y limit is from 1 to 3, and x limit is from 2 to 3, and then dx dy, that value can be easily calculated, isn't it?
Yes, sir.
And we can actually find out the result. All right, so let's see the result. Let's see the result. That is the case that we were talking about. We have seen that this 1 equals to 15C, then the C value has become 15, and then we have used this X and Y, and we have found out that this value will be equals to 2 by 15. Okay, this value will be equals to 2 by 15. So we are actually we are um, so we can actually find out any event probability from this kind of cases. So what actually we have learned today is we have seen the joint PMF. From joint PMF, we have found out the marginal PMF, and then we have seen what is the joint PDF, and from the joint PDF, we can find out any event probability as well. Okay, so actually I will not continue the full class today. I am stopping here, and I hope day by day I'll improve, and I'll continue to take more time in the class. Okay, so is there any question regarding today's class?
No, sir.
Okay, so I'm hopeful that you have understood how to deal with these kind of problems. And remember one thing: after the end of this chapter, there will be a class test. Okay, so try to take preparation from now on. And how many of you are present?
40 students.
40 students.
Yes, from the participant is 40.
Let's 40 students. How many there are in your class?
44.
44. So almost all the students are present. 41 now. So I don't want to give today's